Okay. So, hello everyone. So, our today's topic will be one of the really important topic. Okay. So, we were actually talking about the parallel and the perpendicular line. Okay. So, our today's topic will be parallel and perpendicular line. Okay. This topic is, it's actually really important. Okay. It's actually really important topic. So make sure you understand everything. Okay. So we're gonna start with some of the really important property, really important information first. Okay. So as you can see, I write it over here. Let me actually zoom in a little bit, so to show you guys, a better, a better looking. Okay. So we having a property over here. The property of the slope of the parallel line. Okay, so let me actually read the property first, and then after that I will really explain the meaning of it in a simpler way. Okay, so here the definition says, for non-vertical line y1, L1 and L2, if line L1 have the slope m1. Okay, L1 have a slope m1, and then line L2 have a slope m2. Okay, it have a slope m2. L1, the line, L1, right, is parallel to L2 if and only if m1 equal to m2. So the meaning of that is the meaning of this is that is that the slope of the line L1 and L2 are equal. Okay, so this property, the thing I put over here in the bracket is really important. So make sure you know it. Make sure you memorize as that you know it. Okay, because this is like the condition. This is like a condition. If you want to make sure two lines are parallel to each other, so you can using the slope. As long as the slope of those two lines are equal, then those two lines will be parallel to each other. Okay, so let me actually let me actually repeat this, in a much more simple way. Okay, so the thing over here, the most important thing over here is this. Okay, the thing I circled it, m1 equal to m2. So we got two non-vertical line. Okay, we got two non-vertical line. So non-vertical. Okay, I will explain the non-vertical line a little bit later. Okay, but over here we got two non-vertical line, L1 and L2, and they have slope m1, and then they have slope m2. Okay, and if you want to, the thing over here, right? So L1 is parallel to L2 if and only if the slope of the L1 equal to the slope of the L2. So which means m1 equal to m2. Okay, so this is the important thing. Okay, make sure you keep in mind. Okay, this is really important, really useful information, really important information. So make sure you memorize and then know it. Okay. So here we were talking about this statement a little bit later. Okay, so here the statement say all vertical lines are parallel to each other. So I will explain this in the in the bottom. Okay, in the bottom over here. So let me actually give you some example about the meaning of the parallel line. Okay, the meaning of the parallel line. So we first we have to draw a rectangular coordinate system. Okay, we having an x over here, and then we having a y over here. So everyone know the meaning of the parallel in the graphic is basically meaning something like this. Okay, so suppose you have a line over here, and then you got another line over here, and you can see you can see they are kind of like parallel, right? So everyone understand the word parallel meaning, right? Parallel, right, means they having they kind of like they having the same slope, right? They having the same slope. right? Okay, so that's basically let me write it down. Parallel in graphic. Okay, so the purpose for this graphic is that whenever you see such similar thing, cause we can, cause if we don't have the slope for the line, then if you see like something like this kind of pattern, right? So if you see something like this kind of pattern, then you can basically identify with your eyes. You know that is parallel. Okay, so I just basically want to briefly give you some idea how parallel look like. Okay. So yeah, parallel in a graphic. Okay, let me actually erase this part. Okay. So now I want to talk about something about this part. Okay, I want to talk about something about this part because here the statement, the statement over here is say that all vertical lines are parallel to each other. So so the reason why all vertical lines are parallel to each other is that, okay, so I'm just going to show you why it is all the vertical line is actually parallel to each other in a graphic. Okay, we have x-axis and then we have y-axis. So as everyone know, all the vertical axis is something like this, right? It's actually something like this, right? That is a vertical line, right? That is a vertical line, right? Okay, so as you can see, we suppose here is actually equal to 2. Here is 2, so that means this line is actually x equal to 2, right? And then what about here? Suppose this point is actually -2, x equal to -2. So the statement here is say all the vertical lines are parallel to each other. So the thing actually over here is that you don't even need to know the value of those points. Okay, you don't even need to know the value of this point, but because based on the graphic itself, you can see based on the graphic, when you actually see this graphic, it's parallel, right? Okay, it's parallel both basically based on the graphic. Okay, because parallel, those two lines are actually parallel to each other based on the line, right? Okay, so here is all the vertical lines. So no matter how you actually draw the line like this, you can see all of those 3 lines are also parallel to each other, right? Okay. Okay, so I think that's pretty much enough for for the first property. Okay, so in this property, we're basically talking about how those 2 lines, how you can know 2 lines are parallel to each other in a graphic, or by using the property over here, using this property. Okay, m1 equal to m2. Okay, so let's talking about the second property. Okay, let me actually, okay, I think this is good enough. Let's talking about the second property, the property of the slope of the perpendicular line. Okay, slope of the perpendicular line. So it's the same thing. Okay, let me actually read it. For non-vertical line L1 and then L2, if L1 have the slope m1, and then the line L2 have the slope m2. Okay, then this part is kind of like really important thing. Okay, and L1 is perpendicular to m2 if and only if m1 equal to the -1 over m2, or equivalently m1 multiply m2 equal to L1. So those two are the same thing. Okay, I would recommend you memorizing this one. Okay, I will recommend you memorizing this statement over here. Okay. And the final statement is say the horizontal lines are perpendicular to vertical line. Okay, I will explain this a little bit later. Okay. So the important thing over here is that you need to know that the condition for two lines are perpendicular to each other is basically m1 multiply m2 is equal to -1. Okay, I will recommend you to memorize this. Memorizing this statement. Okay, m1 multiply m2 equal to -1. Okay. So let me. Okay, so right now I just in the example I want to show how perpendicular line looks like in a graphic. Okay. Alright, let me zoom it down a little bit. Okay. So perpendicular. Yeah, make sure you're writing the words right. Perpendicular in graphic. Okay, so right now I just want to show you guys how perpendicular look like in a graphic. Okay, as always, we have to okay, let me actually zoom in. I guess I think that will be better. I just zoom in to show you guys. Yeah. So we always have to draw the rectangular coordinate system, x-axis and the y-axis. So basically, how a perpendicular look like. An easy way to say that is basically you draw a line, right, something like this, and then the perpendicular line will be something like this. Okay. Okay. The important thing is that the meaning of the perpendicular line means when two lines intersect, it forms a 90-degree angle. Okay. Let me repeat one more time. The perpendicular line in graphic is usually is basically two lines. Let me actually write it down. Okay, two lines intersect. Two line intersection. Okay, intersection. Let me actually rewrite these words. Sorry, intersection. Two lines intersection, forming. Okay, let me actually rewrite this. It's kind of like, I think here forming a 90-degree angle. Okay, so that's basically the thing. Okay, that's for the perpendicular line. So basically, whenever in a graphic, whenever you see two line intersection forming a 90-degree line, like here we have a 90-degree angle, and then over here we also call it a 90-degree angle. So if you see something like this, then both two lines, like here we have a line L1, then here we have a line L2, so L1 and L2 is perpendicular just based on the graphic itself. Okay, just basically if you don't know the slope, then you can actually using this. You can basically using your eye. Is okay. Whatever that's another method. Okay, so you see two line intersection forming a 90-degree line, then those two lines will be perpendicular to each other. Okay, that's how perpendicular look like in the graphic. Okay, so now let's basically talking about property over here. Okay, so the property over here say that not the property, the thing over here says that the horizontal lines are perpendicular to a vertical line. Okay, so let me show you why this is actually the case. Okay, so again I'm just gonna show you guys we have to show in this in a rectangular in the coordinate system. Okay, we have the x-axis over here and the y-axis over here. So let's first of all let's actually draw a horizontal line first. Okay, so horizontal lines is something like this, right? Something that is a horizontal line, and then let's say horizontal line are perpendicular to a vertical line, right? Vertical line, let's suppose we have a vertical line over here. Okay, so I think now everything makes sense, right? Everything makes sense, right? As I explain over here, two perpendicular line, two line intersection, the wherever you see two line intersection forming a 90-degree angle, so you know those two lines are perpendicular, right? So here we having, you can see, between this vertical line, so this one is actually a horizontal line, and then the line on the bottom is actually a vertical line, right? So you can see when the intersection over here, this one is 90 degrees, the other side is also 90 degrees, right? Alright, so that means this statement is actually right. So even you put in a line over here, right? You put in a line, you can still see this vertical line, this vertical line is also perpendicular, right? Vertical line, you can see there's a 90-degree angle, right? It's still perpendicular, right? Makes sense, right? Okay. So like, so that's why here the horizontal line are always are perpendicular to a vertical line. So make sure you keep in mind. Okay, you make sure you keep in mind. Okay. Yeah. So that's basically all the property I want to. That's all the really important property I have to tell you guys. Okay. So I think right now is the time for us to actually try some question. Okay, let's actually do some question together. Okay, so I think I only got 4 questions. Yeah. So I got 2 different kind of question, and each kind of question I got 2 problem of it. Okay. So right now is actually the time for you to to actually, if you know how to solve the questions, then basically feel free to actually skip it. Okay, feel free to actually skip it. Otherwise we are basically talking about those questions, really all the questions in detail, and I will make sure you guys does understand it. Okay. Okay, so now let's start with the first kind of question. Okay, so here the question says, it's a better look. The question over here is, you want to determine which two equations represent parallel line, right? The parallel line. As I say, talking about before, if we want to make sure those two lines are parallel, then the slope of those two lines must be equal, right? So that's the condition. You need to know it. Okay, that's the condition you have to really keep in mind. Okay, really keep in mind. Let me actually write this a little bit upwards. Okay, perpendicular lines means m1 equal to m2. So that's the condition you want to check, right? So you want to check it. Okay. So for question 1, as you can see, all of those equations is actually let me write it down. All equation is in line slope intercept form, right? It's actually in slope intercept form, right? So everyone knows the slope intercept form is basically y equal to mx plus b, right? So you can see, so we can basically so we don't need to do anything else. So you can basically, you will know the slope of it right away, because it is in the slope intercept form, right? So let's write it down all the slope. Okay, let's write it down all the slope. So you want to make sure you doesn't miss anything. So that's why you write it down all the slope. Okay. So here you can see the slope. The slope is actually equal to 3, right? Right. Okay. And b is actually equal to -3. So here 3 is equal to 3. Here we got a slope equal to -1/3. So now the condition for us to actually check in the perpendicular line is m1 equal to m2, right? So it's right over here. So you can see for both A and B. Oh, let me actually, I think I make a mistake when I copy down when I writing those solutions. So here is C, okay, this one is C. We got A, B, C, and D. So you can see, like between A and C, the slope are the same thing. So that basically means the line of A and the line between the line of A and C. Those two lines are actually perpendicular to each other, right? And you take a look about B. The slope for B is m equal to -3. So nothing is in common, right? And then you take a look about D. M is equal to -1/3. Nothing is actually in common, right? So the only case over here, the only case two equations are perpendicular, represent perpendicular line is only A and C. Okay, so you can write it down. You can basically write it down. A and C represent the perpendicular line. Okay, so you write down everything, so you will get it all back. Okay. And so A and C represent perpendicular line. So now we solving this problem. Okay. As I say, it's not really difficult. It's basically comparing the slope. Okay, if you're having the same slope, so two lines are parallel. Okay, are parallel. Sorry, are parallel lines. Okay, are parallel lines. Sorry. Okay, so now. The second question says, the second question says, determine which two equations represent perpendicular line. Okay, so now is perpendicular line. Okay, so record the condition for the perpendicular line is m1 multiply m2 is equal to -1. So that's the condition which you want to check it, right? And as you can see, all the equation over here is actually in the slope intercept form, right? Or is it in slope intercept form? So you basically know that the slope intercept form is actually y equal to mx plus b, and all those equations in the slope intercept form. So we can just, we are able to just see, we were able to write it down we were able to find the slope right away, right? So as always, we want to write it down all the slope, because we don't want to, because you write it down all the slope so you don't miss anything, right? Okay. So m for A is actually 5/9. Okay. Over here is actually 6, right? M is equal to 6. Over here is actually -1/6. Over here is actually 1/6, right? Okay. Let me actually check again. Okay, yeah. So now we got all the slope. All right. Now we basically got all the slope. So basically, if you are good enough, you should be able to see, actually, the slope between B and C is, if you multiply the slope. If you hear the condition, right? The condition over here. If you multiply the slope between B and C, then you will get -1, and this is the only case, right? Okay, so if you actually so you're basically doing some calculation in your mind, and you can see, if you multiply the slope between B and C, okay, between B and C, then you are basically getting negative 1. And so the reason, and you can see over here, the slope for A is actually 5/9. So if you multiply the other three, none of them is equal to -1, right? And for part D, for the D over here, is that for D it has a slope is equal to 1/6. So if you try to multiply D to each other, then it won't end up with -1. So that B and C. So the right answer over here is B and C. Okay, those two lines are perpendicular to each other. Because when you multiply, the slope between B and C is equal to -1. Okay. Okay, so let me actually write it down. Okay. Okay. So suppose we say MB. Okay. MB represent the slope of a B is actually equal to 6. Okay, and MC represent the slope of the C. The slope of the C is equal to -1/6. Okay, and you multiply that together, and B multiply MC is equal to 6 multiply 1/6. Okay, you get cancelled. It's basically equal to -1. Okay, so basically now you can now things make sense, right? So I think, yeah, you should basically write it down this. Okay, so now you can basically say B so the graphic not the graphic, the equation, I guess. Write down the equation of B and C represent perpendicular line. Yeah, make sure you all write all the words right. Okay, so now we actually get it down. We actually solve this problem, right? Okay. Okay, so let's move into the. Okay, we got 2 questions left. Okay, so so here this question will take you a little bit more time. Okay, the question over here will be taking a little bit more time. So let's right away to jump into it. Okay, the question over here says, are the pairs of the line are parallel or perpendicular or neither? Okay, so basically, we want to check, are those pairs of the lines are parallel or perpendicular or neither? Okay, so as everyone knows, parallel means the slope are the same, right? The slope is actually the same, and the perpendicular basically means M1. The multiplication between the two lines of the slope is actually equal to -1, right? Okay, so let me actually rewrite this a little bit. It's kind of like a little mess. Parallel means slope are the same, slope are equal, right? And then perpendicular means the multiplication between the slope M1 multiplied by M2 is equal to -1. So keep in mind those conditions, okay? Because we have to using those to, because this is if we using those properties, then we can actually find they are parallel or perpendicular, much more faster, right? Okay, keep in mind with those conditions. So as you can see, the first question says we got in a line, and this line is actually passing through 2 points, right? This line is actually passing through 2 points, and then we got in another line L2 is passing through another 2 points, another 2 points, right? So the thing what we need to really find is we want to find the slope of it, right? So as we talking about this really before, so first thing is we want to find the slope of the L1. Okay, we want to find the slope of the L1, and how you do that? Let me actually record this. Okay, how you basically find the slope is you basically using y2 minus y1 and x2 minus x1, right? So that's basically the equation for the slope, right? Okay, so here let me actually write it down the 2 points first. So we got this point and we got the other point. So those are the 2 points which passes through L1, right? So we got y1, and then we got y2, and then we got x1, and then we got x2. So you want to actually cancel. You want to plug in those numbers in order. Okay, so we got y2 is basically -1 minus y1 is -3, so minus -3. Okay, x2 is 3 minus x1 is -2. Okay, so you write down everything, and then you simply doing some calculation. -1 plus 3 is actually equal to 2, right? 3 minus 3 plus 2 is actually equal to 5. So this will be the slope. This will be the slope for the line for L1. Okay, for the line L1, Okay, and now we now what we want to find is we want to find the slope of the L2. Right, so as I mentioned before, cause we are actually passing through 2 points, so that's the only information what we have. So we have to using this equation. Okay, so basically the reason why we have to use this equation, cause the only information what we have is we know those lines are passing through 2 points, right? So we have to use this equation because this equation is our only option. Right? Okay, so that's why okay, you are not able to using other things to actually find the slope of it, right? So okay, so the point we'll be passing through is -3, 1, and 7, 5. So those are the 2 points which passes through L2, right? x1. Let me actually label it x1, x2, y1, y2, right? So now you want to, plug in those numbers in order. Okay, y2 is equal to 5 minus y1. y1 is equal to 1, right? Okay, x2 is equal to 7. x2 is equal to 7. 7 minus x1. x1 is actually -3, right? So 5 minus 1 is equal to 4. 7 plus 3 is actually equal to 10, right? And then it's basically get cancelled, right? So final slope is actually 2/5, right? It's actually 2/5. That's the slope for L2, right? So now things make sense, right? So basically, you can see the slope of the L1 is actually equal to the slope of the L2, because both of them are 2/5. So those two lines are parallel, right? So two lines are parallel, right? so you can see, the slope are the same for those two lines. So those two lines are parallel, and those two lines are not perpendicular, right? Those two lines are not perpendicular. So let me show you why. Okay. Let me actually moving down a little bit. Okay, well, we don't have much space seating. Don't have much space. Okay. So how you actually showing? So those two lines are not perpendicular. Okay. So how you actually show it's not perpendicular. It's basically you multiply the slope. Okay, you're using L1 multiply the slope of the of the L2, right? So how you multiply? You multiply 2 over 5. You multiply by 2 over 5, and then you end up with 4 and 4 over 25, right? So you going after you multiply the slope, the number you get is 4 over 25, right? And then that is not equal to -1. So that indicates it's not perpendicular. Okay. Okay, so that basically indicate those two lines are not perpendicular. Okay, not perpendicular because after you multiply the slope, it's not equal to -1. Okay, so that's basically, so now we have fully finished this question. Because we already checking, we already checked are they parallel or are they perpendicular? Are they perpendicular, right? So now we have fully complete this question. Okay. Okay, so let's move into the next one. Okay, so the next one is the last question. So pause the video and then try to doing this question by yourself. Okay, pause the video. Okay, so now let's actually doing this question together. So over here, you can see, we having line L1 with equation this. We have a line L2 with equation this, right? Because as you can see, the equation for those lines are not, so you can see, those two equations are not in the slope-intercept form, right? Are not in the slope-intercept form. So the slope-intercept form is basically y equal to mx plus b, right? The reason why I say so the thing is that if you have an equation in the slope-intercept form, then you can easily find right away, right? So that's why I repeat slope-intercept many times, because if it is in that form, then we are able to find the slope right away, right? Because if we want to check, let me actually write it down. Okay? Yeah, so if we want to check two lines are parallel, then we want to make sure is the condition for that is the m1 equal to m2. So the slope of those two lines are equal, right? And for checking perpendicular, then what you have is the multiplication of those two lines is actually equal to -1. So everything over here is talking about the slope. So that's why you want to make sure those equation is actually in the slope-intercept form. So of course that in this form you are able to find the slope really easy, right? You are able to find the slope, right? So the first thing what we have to do is we have to change the equation. Okay, so we have to change the equation. We want to change the equation for the L1 first. Okay, so we want to x minus 3y equal to 6, and negative 3y is equal to 6 minus x. 3y is actually equal to x minus 6, right? X minus 6, and then y is basically equal to 1 over 3x minus 2. Okay. Okay, let me check again. Yeah, so this will be the new equation for L1. Okay, this equation will be the slope intercept form for the line L1. Okay, so now what we have to do is we have to change the equation for the L2. Okay, L2 what we have is 3x plus y equal to 3. So it's much more simple. 3 y equal to 3 minus 3x. So y is just basically negative 3x plus 3. So this will be the this will be the slope intercept form for the line L2, right? Okay, so now we are actually able to compare it. Okay, so let me actually write down the slope first. So you can see the slope for L1 is actually 1 over 3. Right, so it's so we already putting into the line intercept, putting into the slope intercept form, and you can see the slope for L1 is basically 1 over 3. Okay, 1 over 3, and then the slope for L2 is actually negative 3. Okay, the slope of those is slope of L1 is 1 over 3. The slope of L2 is negative 3. So now we want to let me actually move it down a little bit. Okay, so now basically what we want to check are they parallel or not. So you can see M1 is M1 is the slope of the L1 is actually equal to negative 3, and that is basically not equal to the slope of the L2, which is equal to negative 3. Right, so you can see the slope are different. Right, the slope are actually different. So if I actually write this in a much more proper way, so you can basically say the slope of the L1 is not equal to the slope of the L2. Right, those are not equal. So basically that means not parallel. Okay, so as you can see, the slope of the L1 and the L2 as we write it down upwards are different. So they are not equal, so they are not parallel. Okay, so let's talking about the perpendicular. As I write it down upwards, perpendicular basically you have to multiply the slope to the slope of each of the line, right? So you basically multiply the slope of each of the line. The slope is actually the slope of the L1 is 1 over 3, and then you multiply. Let me actually zoom in a little bit, get a better writing. The slope of the L2 is actually negative 3, right? So 3 and 3 get cancelled. It is equal to negative 1, right? So as the condition apply, as you can see, after we multiply the slope of those line, of the two line, we end up getting negative 1. So that means that basically means it is perpendicular. Okay, it is perpendicular. Okay, so it is actually perpendicular. One is not parallel, and the other one it is perpendicular. So those two lines, our final conclusion is basically saying something like those two lines are not parallel because their slope are different. And those two lines are perpendicular because if you multiply the slope of each, then it's equal to negative 1. So that means those two lines are perpendicular. Okay, so hopefully everyone does get the right answer. Okay, so hopefully that everyone does get the right answer. Okay. So let me actually get some summary over here. Okay, so basically in this section, okay, so basically in this section we're talking about the property, the property of the property of the parallel line, right? So we're basically talking about the property of the parallel line, right? And then we also talking about and we also basically talking about the property of how to the perpendicular line, right? The perpendicular line, right? Okay. And we have basically doing some question to demonstrate how we can using those property really well, right? How we using this property to determine it is a parallel line or it is a perpendicular line, right? It is a perpendicular line, right? So basically we have I have been showing how we can using this property to doing those to determine it, right? Okay. And finally, we also I also show you guys how we can let me actually zoom in a little bit. Okay. I also show you guys how to actually solving different kind of question, right? So using some of the knowledge which I talked about in the previous video, right? Okay. So basically make sure you guys have subscribed to my channel. Okay, make sure you guys subscribe to my channel, also like the video. So if you still having some question, please leave a comment below. Okay, so also turn on the notification on. So if there are some new video, you will get a notification. Okay, so hopefully you guys have learned something from this video. Okay, yeah, so see you guys on the next video. Bye bye.